test to identify carbohydrates. We are going to identify monosaccharides, disaccharides and polysaccharides separately. But here we have some limitations to identify these carbohydrates. I'll explain them under the suitable topic. First, I will explain about the identification of glucose as a monosaccharide. Test to identify monosaccharide. Actually, we are going to identify the glucose. So you can prepare a solution of glucose into a test tube. Then you can add a few drops of Benedict solution to the above solution and immerse this solution in a water bath and heat. It's very easy. Then you can observe the color changes like blue, then turns into green, then turns into green yellow, then orange, and finally become a brick red precipitate because of the presence of glucose. I will explain some important factors regarding this Benedict solution. Benedict solution contains mainly copper sulfate solution. You know that copper sulfate is in blue color, so Benedict solution is in blue color. So when you add a little amount of Benedict solution into the glucose solution turns into blue color. This solution turns into brick red precipitate through different color changes while heating. Formation of brick red precipitate confirms the presence of glucose, which is a monosaccharide. This is the identification of monosaccharide. Then we are moving to identification of disaccharide. Disaccharides are the carbohydrates which have formed from monosaccharides. Let's learn about the identification of sucrose. If you can remember, sucrose formed from two monosaccharides. They are glucose and fructose. So there is no direct test to identify sucrose. So you have to hydrolyze this sucrose into glucose and fructose first. So I will explain the steps to follow. First, you can prepare a sucrose solution into a test tube. Then you can add a few drops of diluted sulfuric acid into that test tube. This is the step that you hydrolyze this sucrose into glucose and fructose. In this solution, there are glucose. So you can add Benedict solution into that solution and heat. Then again, this solution turns into brick red precipitate from blue color, like in the previous test. This is the test to identify disaccharide. Can you imagine what would happen when you add a little amount of Benedict solution into a sucrose solution directly and heat? You can't see anything, any observation here, because sucrose cannot produce any response with Benedict solution because sucrose is not a reducing sugar. That is the reason. You will learn about the reducing sugars in advanced level. You don't need to worry about that. Okay, you have to hydrolyze this sucrose into glucose before identification of sucrose. That is the main step you need to remember. We are moving to the test to identify starch. This is very easy. Starch is a polysaccharide, so we are going to identification of polysaccharide as well. We can say that. So you can prepare a solution of starch into a test tube again, like in the previous test, and you can add a little amount of iodine solution into the above solution. So you don't need to heat this starch solution. This colorless starch solution turns into purplish blue color because of the iodine. There forms a complex between starch and iodine. This complex is in the purplish blue color. Because of that, we can identify the starch in the solution. This is how you identify polysaccharide. So we have discussed about the identification of carbohydrate. Under this topic, we discussed about the identification of glucose, sucrose, starch according to the monosaccharide, disaccharide and polysaccharide order.